Hey, from the Retro Handyman. I have a small garage in the UK where I repair consoles and old computers, and today we're going to have a look at an old Megadrive that has a graphical glitch. I have previously repaired the plug on it because it was not working very well, but the glitch is still there, so I think we should go and fix it.
In the process, I've also acquired an original Sega power supply which is busted, and I hope to repair in another video. And because I have no proper power source, I'll have to hook it up to my variable power supply. It's a little tool that allows me to power almost anything.
Okay, let's see the problem.
As you can hear, we have audio, but the screen is very garbled. Also, do apologize for the flickering of the screen. It is my first video, but I have already read how to sort that out. Anyways, back to the video. You can see something is happening in the background and things are moving. Not everything is stuck. It seems like individual chunks of graphics are messed up by themselves. But overall, the big picture is still visible. You can clearly see Sonic go about his path.
That kind of glitch, usually it's the VPU or the VRAM. I'm more inclined to say it's the VRAM this time because the general flow of the game is working first of all, so you can see the sprites are moving in the right positions and everything. It's just the graphics are glitched, they are wrong, but the movement is right. So that is my first guess. And secondly, usually the VPUs don't go wrong as often as the VRAM. The VRAM is the one that goes bad sooner, or more often, let's say, in these consoles. So let's have a look inside.
For those of you who don't know, VPU stands for Video Processing Unit, and it is usually one microchip that takes care of rendering, in this case, game graphics. This chip then stores the data it generates in small memory microchips, commonly referred to as VRAM or video RAM. Interestingly enough, the VPU is called PPU, which stands for Picture Processing Unit in the Super Nintendo, and GPU, which stands for Graphics Processing Unit in modern PCs. Okay, so here's the main board. I'm moving to the top here. You can see my repair and enhancement. I added a connector so it would be easy to separate the plug from the board, as the existing connector is very hard to pull off. Here we have the main chips, the Motorola 68000, the graphics processor and the bus arbiter. The Z80 here to control audio. The RAM modules are here, 72K. And finally the two 32K VRAM modules that I suspect to be the cause of our problem. I'll be replacing the VRAM chips with some identical ones I bought off eBay. Also, I want to socket these ICs for easy future replacement. Because the pins of these IC are shifted between rows, I will have to use two single line IC sockets.
Anyways, back to the board and let's go desoldering.
I have a desoldering gun which makes the process much faster compared to using the soldering blade. After the soldering, I usually bend the pins a little bit to facilitate the extraction afterwards. They click a little bit when they release from the solder. Okay, so I pulled the VRAM out, but I might have pulled a little bit too hard. Now you can see my chip extraction efforts on this poor fella. He's gone for good. It's not super bad, but I could definitely have done better. Fortunately, there are no broken traces, so I think I'll test my luck on this one. Here's the soldering done. And here's the sockets in place for the first chip. And here's a new replacement in. It's looking really good. Take some moments to admire before testing from various angles. Now for the moment of truth. Will it turn on? Yes! It was the right one! Whoa! It was the right one. Out of the two, I was 50%. And it was the right one.
Well, that was a lucky strike. I mean, it was 50% chance it was the VRAM or the VPU, and it was the VRAM, and I had only enough stuff to replace one, and it was that correct one. So now I think it's time to clean it all up and then put it back together.
In this case, I'll wash only the top part of the chassis. as the bottom part is pretty clean. I won't use any special plastic refurbishing products as I already have a Megadrive with a very good outer shell. Just a good wash with brush and soapy water. Oh, there was a small accident when putting it back together. The LED light cable popped off. I'll have to solder it back on. And 5 minutes later, it's done. To avoid similar problems in the future, as you might have already noticed, I fitted the LED with a socket, so it's easy to pull off. Now let's close it back up at the speed of light.
Okay, time to test it again. Now it's all closed.
Let's turn the power on. And success! Megadrive is working as good as new. A pat on the back for me. Notice I fixed the screen flickering problem, mostly.
Well, I'm glad I managed to save another Megadrive from the tip. It was really lucky. I hope you guys enjoyed this video and found it useful. If you did, please thumbs up. A subscription would be great, really great. Until next time, take care, stay safe.